This is Rough Science, coming to you from the Spice Island of Zanzibar off the east coast of Africa. Our scientists face their toughest trial yet as they take on the ocean. They have to complete a set of marine challenges with a few simple tools, some basic bits of kit, and a boatload of ingenuity. Our base on the Indian Ocean is a traditional fishing dhow, and our site on land is an isolated beachside workshop. It's destination paradise for rough science. Our 4 scientists are Kathy Sykes, a resourceful physicist with boundless energy. Yes! Mike Bullivant, an imaginative chemist who embraces the near impossible.
Oh my word!
Ellen Macaulay, a fearless have-a-go botanist from Missouri.
Next thing is rinse it.
Jonathan Hare, physicist, inspired inventor and artistic engineer. And me, Kate Humble, an experienced diver. I'll be going underwater to put their inventions to the ultimate test. Together we are Rough Science.
I had a curious premonition last night that in 3 days' time I'm going to be on a boat that's going to get into trouble and I'm going to have to abandon that ship. So I'd like to be prepared for every eventuality. So Mikey B, could you make me some sort of signalling device, a distress flare, if you like, to pinpoint my position for any potential rescuers? And then Kathy and Ellen, if you could come up with something that's actually going to keep me afloat in the water, potentially for quite a long time.
If it does rescuing you, yes.
And then Jonathan, the other part of this premonition is that it might happen in the dark. So, do you think you could come up with some sort of beacon that could be on the flotation device, so that when those rescuers come scampering to my aid, they can find me?
Okay.
So, you have 3 days, everything in the workshop that you can use, anything you can find around here, and the magic trunk, and please don't fail.
This week, the trunk is very bare.
That's sugar cane, isn't it?
Yeah.
And the challenges are going to be a real test of the scientists' ingenuity. They have no choice but to rely on the natural resources of the island. They've got until nightfall on day 3 when I'll be in the water, in the dark, and in need of rescuing. The currents in the waters around Zanzibar are fast and strong, so as far as I'm concerned, failure is not an option.
So I'm beginning to regret being a scientist's human guinea pig. The sea is not looking much fun this morning.
Mike's wasting no time. He's heard about a local cave system that's home to a colony of bats. It's a long shot, but he's hoping to extract one of the chemicals he needs for my flare from their droppings. It's a dirty and potentially dangerous job.
Now then, Jonathan Hare, how are you going to come up with this hugely bright light for
Well, I don't
me?
know about that, but the radio had lots of these little lights on.
Okay,
So I reckon I can use these because they're very low voltage little bulbs.
But tiny,
They
Jonathan.
are.
No one's going to see those.
That's all I've got. And I've got quite a few of them. And hopefully, maybe if I can flash them or something, pulse them, then they'll be brighter. And if it's pitch dark, even in the roaring sea, you see that.
Okay, so how are you going to power them?
Well, you know a car battery has acid in it?
Yeah.
Well, basically, every battery needs a liquid, an electrolyte.
Right.
But we can use seawater. It won't be as powerful, but I'll show you. Basically, if you take 2 different metals and you put them in seawater, you get a voltage produced and you actually see them. Can you see on the meter?
Oh, yeah. God, that's brilliant. So as I hit the water, the seawater will kind of flood into the works and make everything work?
Yeah, yeah.
So is that enough voltage that could power a light, basically?
No, not really. That's the tricky bit. I've got to think of some way of doing it. But
Think hard on that, indeed. And I want bigger bulbs, Jonathan. I'm worried about those bulbs.
well, that's all I've got.
If Jonathan can't increase the voltage from his battery, it's not going to power any lights, however tiny. So I'll have no beacon and a life jacket that looks like a couple of old pillows.
And I'm hoping that this is stuffed with K-pop fiber, because that's typically what people stuff pillows and mattresses with. And I've seen a lot of K-pop trees on this island.
And how does K-pop help us?
Well,
how does it work?
Historically, it's been used for life preservers, so I figure we're going to be making a life preserver. There we go. Yeah, this is the stuff. The fiber comes out of the seed pod. And this has a slightly waxy coating, so it's slightly water resistant, which is helpful. But also, it's pretty buoyant until it gets matted badly. And this is still pretty fluffy.
Okay, but we'll have to coat it with something, presumably. I mean, if we don't do a pillow into water,
Right.
and you held it under with a weight like Kate's, then it would just get logged and sink, wouldn't it?
And that's where this comes in. This is a rubber knife. I've seen a lot of rubber trees on the island, so I think we can tap some rubber.
Ellen and Kathy plan to use rubber to make a waterproof coating for my life jacket, but first they have to design it. Mike's explorations have taken him nearly half a kilometre underground, but he's finally found what he's looking for. It's not just any bat droppings that will do, though.
It's not the top surface of the bat droppings I want, it's the lower surface, because they'll have been there for longer. And the biological action will have converted the bat droppings into one of the chemicals that we want for our flare. But it's so hot down here, you wouldn't believe it. Okay. Oh, no.
Back at base, Jonathan is in better spirits than Mike. He thinks he's found a way to increase his battery power using an ice cube tray and a few zinc screws.
I've got a metal screw and a carbon rod, and these are both conductors of electricity. And when I put these two conductors in the seawater, chemistry goes on. What happens is charged metal atoms come off into the salt water, called ions, and make the metal screw charged. The same thing happens, or similar thing happens with the carbon, but to a different extent. So one becomes positive, one becomes negative, and that difference in charge, plus and minus, is the voltage. And so we've made a little battery. Now what I've done is I've wired up 6 of these, one after the other, so that we can add the electricity from all of them, and you can see it goes right up to almost 5 volts, which will be about right, 6 times the single one. So we're able to get more energy by joining these up.
So it looks like Jonathan has found a way to produce enough electricity to power my beacon. For the rest of the team, progress is taking a little bit longer. It's an afternoon of sewing, digging, and some more sewing.
I can't imagine how this is going to save my life.
And then Mike finally returns from the bat cave and starts demolishing the sugarcane from the trunk.
Now, Bullivant.
Yes.
Oh my God, what is that?
This is going to be your flare.
Talk me through this flare then. What are you going to do?
Well, the idea is I'm going to make a rocket-type flare. You'll
Okay.
be able to shoot up in the air.
What, like a beautiful firework?
Yeah, it's a firework. I need gunpowder.
Okay, and what does a rocket have to do with that? What is it?
Well, this is bat droppings in here.
Of course
we
it
collected.
is.
We drop the bat droppings in water.
Right.
And the bat droppings contains a chemical, potassium nitrate, which I need for the gunpowder. It's one of the 2 chemicals I need.
Okay.
The potassium nitrate will dissolve in the water, the hot water, so I filter off anything that doesn't dissolve, so I've got a solution of potassium nitrate. The other chemical I need for the gunpowder,
Yeah.
for the rocket, is sugar. And you gave me some sugar cane in the trunk, didn't you?
So you're extracting the sugar from the cane?
Yeah, it dissolves in water.
So you'll end up with kind of sugary water and potassium nitrate-y water.
Yep.
And that's your gunpowder,
Mix
basically.
those 2 together, dry them out, evaporate off, get a solid. That's your gunpowder.
And then, just when I thought things were looking up, Jonathan has come up against a tricky design challenge with his battery.
The problem I've got, of course, in the ice cube tray, all the liquid is separated. Imagine now putting this in the sea. The problem is, because the seawater is conducting, it shorts out all of them and we're back to a single cell. So the next big challenge that I've got to do is got to somehow let the water in to make the battery work and make sure they don't all short circuit.
Not great news, considering it's the end of day 1 and my life is in the hands of some tree fluff, a pot of bat droppings, and the tiniest light I've ever seen. It's 6 a.m. on day 2 and a very early start at the rubber plantation for Ellen and Kathy.
Okay, first thing we do is we remove the rubber from the last time the tree was tapped. Still really elastic. Then,
There's your tool.
yeah, and all we want to do is take off a very, very thin layer. You see how it starts?
Coming already?
Yeah, it flows immediately. Okay. Then, before it starts flowing, you just set it up.
Fantastic.
Isn't that amazing? The reason we're here so early is because this is when the latex flows really fast. The trees will stop running about 10 o'clock really fast like this. We'll collect all the rubber and head back to base.
Doesn't this damage the tree?
Actually, not much, because all we're doing is cutting into the inner bark, and the latex is actually like a protection layer.
So this is like an outer protective shell for the tree?
Mm-hmm.
Wow.
Next,
Let's do it.
Your turn.
Back at base, Jonathan has an idea which he hopes will solve his short circuit problem and keep my beacon alight.
I want the water to go in, but I don't want it to be immersed in water because it will just short circuit the battery. So I'm using the sponge so that when it falls in the water, the sponge will take up most of the seawater, and then hopefully it can be on the thing that Kate's going to wear, and all the excess water will fall off, but the sponges will keep the seawater next to the electrodes. So it's just a mechanism by which I can get water in, keep it where it needs to be, and make sure it's not where it shouldn't be.
At the rubber plantation, tapping is interrupted by unexpected visitors.
Ow! Help. You see all these ants?
Oh my God.
Yeah, they bite. Look at that. Look how hard they hold on. See that?
It's like they're doing it for their life, isn't it?
But you know what they do? They're protecting trees. And that's their job.
Doing a good job, aren't
Yeah,
they?
so we're disturbing, when we
Turn around,
disturb
you're
the
done.
smaller trees. But in the Amazon, they use ants like this as sutures because once you can pull their body off, but once they've bitten in, they don't come off.
Let's get out of here, Ellen.
You gotta come back to get the rubber in an hour.
By the end of a long morning's work, Ellen and Kathy have a bucket full of liquid rubber. Whether they can turn it into anything useful remains to be seen. It's lunchtime back at base, but Mike won't take a break.
I want to get as much sugar out of this sugar cane, and I think I'm going to do that by cutting the sugar cane up into small, very small pieces.
Mike won't know if he's been successful until he reduces down and then cools the liquid in the pot. At this stage, the sugar should crystallise out. Meanwhile, the bat droppings are taking even longer to deal with. He's got to boil up and painstakingly filter both bucketfuls to have any chance of extracting some potassium nitrate.
This is...
Latex. And if we process it, it turns into rubber.
So we're going to waterproof your life jacket using this, is the plan.
Wow, so what do you need to do?
Well, the first step is we need to add acid so we
Okay.
can thicken the latex.
Oh, okay.
So if you just squeeze that into there.
Lemon juice will start the sort of
Yeah, lemon
gumming
juice,
up process, will
Lemon
it?
juice is an acid.
Right.
And so just a moment ago, we poured about the same amount as we poured in here,
Yeah.
added lemon juice, and we didn't move fast enough. And this is what we ended up with.
Now you'll see this isn't really strong enough, it's not elastic enough, it just breaks
Yeah.
too easily. It's
Yeah.
not like rubber.
Right.
So once we add the lemon juice, then we start to vulcanize it.
What does vulcanise mean?
Well, it's all about making it harder, making it tougher, making it more elastic.
Right.
So we add the fabric,
Yeah.
and then we'll spread it out over the heat and the smoke,
Yeah.
and it'll start to vulcanize.
But to help, what we're going to do is add a bit of sulfur. Now imagine that in here there are lots and lots of rubber molecules, and they're all kind of little strands like this waving around. Now, when you vulcanize it, you cross them together and form little bridges between them, and you form a net.
Yeah.
And that net you can kind of stretch, and then it will bounce back because of the little sulfur bridges.
Okay. So this whole process is going to mean that you then have something absolutely workable and hopefully, for my sake, waterproof.
Strong, elastic, waterproof.
For Ellen and Kathy, it's time to put the theory to the test.
Okay.
the moment of truth.
You do it on one side. Oh, look, it's sticking. Yes, it's coagulating.
Great. Give it a good squeeze.
If the vulcanising goes to plan, this section of the life jacket should end up with a flexible, waterproof coating of hard rubber. Down at the beach, Jonathan's having a nervous moment of his own. It's time to test his seawater battery in the sea.
This is a really important test for me now. What I'm going to do is I'm going to plonk this in the water, fill it up with salt water, and then shake the thing, and hopefully the salt water will only stay where it should do in the foam, and it should fall off everywhere else. And so consequently not short-circuit the battery where it shouldn't be. So I'm hoping that when I put it in, the meter reading may show some reading, then when I shake it, it should go shooting up. That's what it should do. I am a little bit nervous because if this doesn't work, I'm completely back to the drawing board on this one. So this has got to work. It's got to work. Okay, here goes. Okay, we've got a little reading now, about a volt, which is what I expect. Now, if I shake it, yeah, look at that! Brilliant. So it's not short-circuiting. I've got about 8, 9, almost 10 volts. That's what I wanted. Oh, that's great news. So we've got almost 9.5 volts there, which will be more than enough to power our little lights.
But it's not such good news for Ellen and Kathy.
This is our life jacket.
It just wasn't a good idea to sew it, was it?
No, and then dip it.
It's just all stuck together rather horribly, like a sad Christmas stocking. It's not going to save Kate.
I don't think Kate would be impressed at all.
So yesterday's entire day of sewing was a waste of time. Ellen and Kathy are going to have to start all over again.
Oh, shoot. It's really
Is
being
it great?
Their new plan is to rubberise the fabric first and then stitch it together to make the life jacket. For Mike, Ellen and Kathy, it's going to be a long and sweaty afternoon.
Oh, whoa, 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 whoa. Stretches. And you don't think it's going to happen.
Even Mike is beginning to lose faith.
I don't think the bat droppings were old enough, because in the bat cave they were only that deep, and even though we dug the bottom layer, you know, they were fresh bat droppings, I think. And the older the bat droppings, the more potassium nitrate you're going to get. And I won't be able to test it until later on this afternoon when I reduce this right down.
It's just so much harder than I thought it would be.
With 24 hours to go and no flare and no life jacket in sight, I'm relieved that Jonathan, at least, is feeling more optimistic.
Okay, so she's weighing the life jacket round her. The battery's going to be right next to her, and then there's going to be a pole with the lights above her. So I made a little holder for the lights, and they go to a little switch. I've just got a little spring here, and so when Kate moves around in the water, that switch makes contact momentarily, so it's going to flash the lights on and off. Wired it up to one of the seawater batteries over here, and you can just about see the lights flashing. I think that's going to work.
So Jonathan is nearly finished. And even Ellen and Kathy have something to show for their day's work. The question is, has Mike managed to extract the 2 chemicals he needs for my flare?
Right then, Mikey B.
Yeah.
All I've seen you do today is be crouched over this fire. Have we got any results yet?
I think we have. This is the sugar solution,
Yeah.
which I've cooled in ice water.
Yeah.
And I hope the sugar should crystallise out of the water. Can you see
there's
that
something in
solid
the
at the
bottom
bottom?
there. Yeah.
That should be sugar.
That
what it is.
is one of the components that you need for gunpowder.
Yeah, that was the easy part. This is the difficult one. This is
Yeah.
the essence of bat droppings.
Yeah.
But I've soaked this paper in the solution,
Yeah.
dried it out. Now, if there's potassium nitrate in the bat droppings,
Yeah.
then this should burn like a fuse slowly. It should produce a bit of smoke, and it should burn with a lilac flame.
Okay, go on, go on, go on.
Fingers
go on.
crossed,
Yeah, all right,
fingers
all right. I've got
crossed.
them all crossed. And toes. It's not burning, Mike. Oh,
Oh, wow, we've got it. We have it.
fantastic!
We have it.
Oh, it's
That
almost like a
is
firework on its own.
I could cry.
Brilliant!
We've got both the chemicals for the gunpowder.
It's the beginning of day 3, and there's less than 12 hours to go until I meet my fate.
Look at this!
It's just amazing.
Wow, and it's even elastic.
It's like Macintosh. It really is like Macintosh.
Hey, and yesterday it was so tacky,
Yeah.
you could barely work with it. It just kept sticking to itself. And although it's still a bit tacky, it's so much more workable, which means it's pretty well cured. The vulcanizing's worked.
Well, I think we're ready to test it for waterproofing.
Okay,
So I'm going to pour some water on top of it.
right.
And if it's waterproof, it should go rushing off. And if it's not, it will absorb into the fabric.
Okay, let's see.
Ready?
Yep. Look at that! I have to say, you know, they are like Macintosh, but it's not much like a life jacket yet.
We've got a lot to do today, Kate.
Yeah.
Mike also has a long way to go on my flare. As well as the casing, he has to work out how to launch it. But Jonathan has offered to help out.
Well, I'm trying to think of a way that we can safely detonate these flares that Mike's going to make. We've got some nice little lighters here. So I'm thinking maybe we can have a string going back that Kate could pull, which will detonate the lighter, which will then fire the flare.
Meanwhile, Mike is keen to show me his finished gunpowder. It may look like muesli, but he assures me it's a dried-out mixture of the sugar and nitrate solutions.
What's chemistry? Oh, wow! Oh, my word!
That's not muesli.
That is definitely not the music. That was amazing. So what is it about those two ingredients, the sugar and the bat poo, that make that happen?
Well, the sugar is the fuel,
Right.
and the potassium nitrate provides a source of oxygen to allow the fuel to burn. But you see, all of the solid is gone. It's just converted to gas.
Totally gone. OK, so clearly I don't need any more proof. It burns beautifully. But how does it make a rocket go...
Well, this is the rocket casing.
Yeah.
We'll just pack this rocket casing with the gunpowder
OK.
and then seal it very tightly at this end so that when we burn the gunpowder, it produces all those hot gases.
Yeah.
It comes out through this exhaust. See that tiny hole?
Right.
That's called the motor.
Yeah.
And as the hot gases are forced to come out through here,
Yeah.
Newton's law says that there's a reaction to that and the rocket flies in that direction.
So that is what provides the lift, or the thrust, basically, is the exhaust fumes coming out. So, are you feeling confident?
I am feeling confident. We've still got plenty of time to play around as well.
Kathy and Ellen are also feeling pleased with themselves. They've managed to find a way out of doing any more stitching. Instead, they're soldering my life jacket together.
Anything to avoid sewing.
Anything to avoid sewing.
When it comes to the stuffing, Kathy has decided it's going to take more than kapok to support my weight.
I think this is Kate's life at stake, Ellen. We have to do everything we possibly can.
For Mike and Jonathan, the countdown to their test launch begins. They need to know if Jonathan's lighter detonator can ignite the flare from a distance.
OK, man. You ready?
Yep.
No lift-off yet.
OK, I'm just going to make sure that's in the flame properly. OK, that looks good. OK. Is it going to go? Oh.
Nope, and things aren't going to plan for Ellen and Kathy either. Their efforts to avoid sewing have got them into trouble.
We are melting solid glue to try to make a seal, and it's all because once the kapok gets onto the rubberized material, it stops it from sticking to itself. So this is our last resort.
Jonathan and Mike still can't get the lighter mechanism to work.
Well, there's fuel in there, Jake.
Maybe we have to go for the electric ignition.
So it's plan B, electrical detonation.
So basically what you do is you have a very thin electrical wire which goes into the rocket, and you wire that up with really thick cables to the car battery, and that glows red hot and will light the gunpowder. But as ever, time is the big factor.
I think we've got about an hour to go. Don't say that. And we still have to stick the last bits of seal, make the ropes, and go over a few bits and pieces that didn't stick the first time around.
It'll be all right. Right?
Whoa! No, we've lost. Oh, look at that.
It's still burning.
It's still burning.
Shall I swim out and get it?
Yeah, I think we have to. It's the only stick we've got.
In the nick of time, Ellen and Kathy finish my life jacket just after sundown. But whilst the scientists' work may be done, my duties are just beginning.
Wow. I have to say I'm feeling a little nervous, but this looks good. Do you think it's going to float?
The most beautiful life jacket on the planet.
It is very beautiful.
Float anywhere you'd like.
And just
What do
tie
I
it
do
up
with that?
Really tight round here to keep it on you.
Okay, okay, fine.
Brilliant.
Mikey B?
I made you a flare.
Fab. Have you got anything for me?
Yeah, and when you fall in the water, this goes into the seawater.
Yeah.
And then you lift it up out the seawater
Yeah.
and the lights will flash.
Okay. I feel rather like Queen Victoria, actually. Okay, here's the plan. When it gets really dark, I will set off Mike Bullivant's flare. Please have your eyes open for it. It's me, and I will need rescuing.
Will do.
We will.
Okay.
Good luck. Please, please
fun.
say I'll see you soon. See you soon.
Can't see anything.
Well, it's a beautiful night. It'll be even more beautiful if this flare works.
Woo! There it is! Over there, wow.
Let's go.
Okay.
Let's go.
Let's go.
The hurricane lamps.
I'm now going to plunge this in. Oh, look, my LEDs are working. They're flashing. I hope the current hasn't taken it too far. Life jacket's working a treat. I think Ellen and Kathy have earned full marks for that.
Can anybody tell how far out she was?
300-400 meters.
400, maybe even 500. It's quite a long way.
Where are they?
Let's get to the front.
Oh, I think I can see them. I hope they can see me.
Oh, it is.
Where?
It is.
Look, it's moving really fast. Oh, she's to the left-ish.
It's red.
The red. She's moving quickly. Yeah, she's moving really quickly. It's a strong current. Faster, though.
Come and get me!
We're coming! Faster!
Can you see my light?
Yes!
Hooray! I have to say, for a rescue crew, you make your victims swim quite a long way. Can I come in now? All right, here we are, trying to grip on you all. Well, I have to say, it is very totally declare that the flare went off. The life jacket did indeed save my life. And the little LEDs, I mean, they lit for me. You were the ones looking for them. Could you see them?
Yeah, we could. In the distance.
Thank you all very much indeed, and congratulations. And that's all for this week's Rough Science, but join us next time for more. Well,
Next week, Ellen makes a mosquito repellent, and we have a look and a listen to Zanzibar's underwater world. For a free magazine about all Open University programmes, call 0870 900 9581 or go to open2.net, where you'll also find more about this week's challenges.